In example 5, solving a higher degree quadratic equation by factoring. Solve the equation by factoring. We have negative 3x cubed minus 5x squared minus 2x is equal to 0. So we're going to set that equal to 0. In step number 2, we want to always ask ourselves, can we factor something out first? So what we can factor out is a negative x, because you always factor out the negative symbol if it's at the beginning of the particular equation. So factoring out negative x, what we have left is 3x squared plus 5x plus 2. Now don't forget this negative x because we need to include it as part of our step 4. Now we have 3x squared plus 5x plus 2, and there we can see that it's not a leading coefficient of 1, so we have to use the AC method again. So we take a and multiply it by c, which is 3 times 2, which gives us 6. The middle number is 5. So what two numbers can you multiply to get 6 that when you add them together it gives you 5? Is 2 and 3. So rewriting the first term, we have 3x squared. The two middle terms become plus 2x plus 3x, and the last term is 2. Now we're going to group the first two terms together and the second two terms together. Now what can we factor out of the first two terms? We can factor out an x, and what's left is 3x plus 2. And whatever we get over here, we immediately write over here, and we ask ourselves, what number do we need to multiply to get 3x, to get multiply by 3 to get 3, and what do we need to multiply by 2 to get 2? Well, the answer is 1, so we have to factor out a 1. So we end up with 3x plus 2 times x plus 1. And so now remember that negative x, we brought that down here that we already factored out, and then we have times 3x plus 2 times x plus 1, which is equal to 0, because we're using the zero product rule. So I want you to notice that we have 3 factors, 1, 2, 3, and we should have 3 factors, because when you take a look at the very beginning, the highest degree is 3, which tells us that we have 3 solutions. So we're going to set each of these equal to 0. We have negative x equal to 0, or 3x plus 2 equals 0, or x plus 1 is equal to 0. When we solve the first one, dividing both sides by negative, we get x is equal to 0. The second one, we're going to subtract 2 to both sides and then divide by 3. So x is going to equal negative 2/3. And the last one, we're going to subtract 1 to both sides, where x is equal to negative 1. So now we have 3 solutions. Negative 1, negative 2/3, and then 0. So when this is graphed, you should see that it crosses the x-axis 3 times. The first one is at negative 1, 0. The next one is negative 2/3, which is the same thing as negative 0.6670. And then the third one is 0, 0.